Hello, my name is Kath. I'm one of the maths teachers here at Huddersfield New College, and today we're going to be looking at a little taster lesson on A-level maths. A-level maths is all about graphs and algebra. There are other things in it, but the big part of A-level maths is algebra, so that's what your skills need to be in. So we're going to look at what sounds like a simple question of sketching a cubic graph. But to sketch a cubic graph, there's actually quite a lot of stages in it and a lot of different parts of maths to be able to do it. So what I'm going to do is have a look at the equation of y equals x cubed minus 4x squared minus 4x plus 16. And to be able to sketch that graph, we need to look at where the graph will cross the x-axis and the y-axis, and we also need to look at things like maximum and minimum points. So at GCSE, you should be familiar with what the shape of this curve is. So it's a positive cubic graph, so it's looking like that kind of shape. And we know it's positive because our x cubed is a positive x cubed rather than being a minus x cubed. If it was a minus x cubed, the graph would be doing that kind of shape. So we know it's not that kind of shape. We know the shape of the graph, but now we need to find some coordinates. So the first thing we can do is look at where the graph will cross the y-axis. So if we just do a little sketch over here of the y-axis and the x-axis, we will see that we're going to cross the y-axis when x is 0. So if we say when x equals 0, substituting the x is 0 into our equation, so y equals 0 cubed minus 4 times 0 squared minus 4 times 0 plus 16. And we should be able to see 0 minus 0 minus 0 plus 16. So y equals 16. So I know that my graph is going to cross the y-axis at 16. I know the shape of the graph. I know it's going to cross at the y is 16, but I don't know where the graph is going to be at the moment. So it could be a graph that's doing something like this and crossing through at 16. It may be that the graph is crossing 16 first and going off. I don't know where it's going to be at the moment. So I need to do a little bit more work. And one thing we can do is look at where the graph crosses the x-axis. Now in A-level maths, you do something called the factor theorem. So I'm not going to go into it too much detail at the moment, but the basis of it is the same thing as before. If y is 0, then we know where the points are where it crosses the x-axis. So if we can figure out a value for x, which will give the answer to our equation as 0, so y is 0, then we've got where it crosses the x-axis. So I'll give you an example. If we said x equals 1, and we substitute it into our equation, so y equals 1 cubed minus 4 times 1 squared minus 4 times 1 plus 16. And we're going to try and see if our answer is 0. So what we've got 1, we've got minus 4 and plus 16. But our answer isn't 0, our answer is actually 9. So all that's telling me is that one of the points on the graph is in the coordinates 1, 9. So 1, 9, somewhere over there. But that doesn't really help us. So we'll try another one. So we'll try when x equals 2 and do exactly the same thing. So I'll get 2 cubed minus 4 times 2 squared minus 4 times 2 and plus 16. So we have got 8, we've got minus 16, we've got minus 8, and we've got plus 16, which does come out to be 0. So that means we have the coordinates of 2, 0. So I know one of the points called the roots of the equation is going to be when x is 2. So we'll do the same thing to try and find the other values. But to cut this a little bit short, because we're doing the same thing, I can tell you what they are. So one thing we've got is that our x value is 2, but if we were to factorise our cubic graph, so factorise put into brackets, one of the brackets must be x minus 2. We then have another 2 brackets with x and a number on there. So we can use the same theorem to try and figure out what the other 2 are. The reason why this is x minus 2 and not x plus 2, as we found before, is that we want this bracket to be equal to 0. So if x minus 2 equals 0, that means x must be 2. So that's one of our factors of our cubic equation. I'll let you know what the other ones are now. So it's actually x minus 4 and x plus 2. So that is given us our roots are when x minus 4 equals 0, because anything times 0 is 0. So it means our other root must be at 4, and our final root is when x plus 2 equals 0, so x is minus 2. So if we go back to our sketch, we know that we've got the roots are going to cross the graph at minus 2, 2 and 4. So now we've got a much better idea of where our graph is going to go. We've still got a bit of missing information. We know the shape, we know where it crosses all the axes. So we're going to go up here, it's going to come down, and it's going to go off up to the top. But what I don't know at the moment is actually what the coordinates are of that maximum point and that minimum point. And that's the next thing that we need to look at. So I'm going to go on to the next page. So I'll just write the equation again. Okay, this bit of the taster lesson is going to look at the maximum minimum points, which is also called stationary points or turning points, which you'll probably know from GCSE. So what we need to do, the reason why we're going into now, we're going to go into calculus. So I'll give you a little example of why we're using calculus here. We're going to differentiate our equation. And when we differentiate our equation, it tells us what the gradient of the curve is. So the gradient of the curve is if you take a straight line and you just touch the curve at any point with that straight line and work out the gradient of the straight line, that will then tell you the gradient of the curve at that one point. So you'll have to excuse my diagrams. Yes, it didn't quite touch, but if it just touches the graph, then we can work out our equation by finding the change in y over change in x, and we've got the gradient of the curve at that point. So if you think about what's happening to the gradient, where we've drawn the gradient at this point is a positive gradient. We're getting a little less steep, and at the top we go horizontal, and then round to the other side it becomes a negative gradient. So we've gone from a positive to a straight line to a negative gradient. That means a straight line at the top must have a gradient of 0. And we're going to use the fact that the maximum point and the minimum point has a gradient of 0. Okay, so when we use calculus and we differentiate, we're finding the gradient function. So when you do A-level maths, there will be whole lessons on differentiating from first principles, a lot more work in it than we're about to do today. So I'm just going to give you a very quick, short version of how to differentiate. So when we differentiate, we find the gradient function. So if you remember working out the gradient of a straight line, it's a change in y over change in x, which we would write as dy by dx. We take the power and we multiply by the power and then take 1 off the power. So that's a quick and simple way of differentiating. So we're multiplying by 3, so it's 1 times 3 is 3. Take 1 off the power and it becomes a power of 2. Here we've got a power of 2 times minus 4. So we've got minus 8. Take 1 off the power, these just leave us with minus 8x. Here we've got a power of 1, so we multiply by 1, so we get minus 4. X to the power of 1, take 1 off the power and we get x to the power of 0. So anything at all to the power of 0 is the answer 1. So it would be just the same as saying times 1 instead of x to the power of 0. The final one, there's no x here, but we could say it's 16 x to the power of 0, because x to the power of 0 is 1. 1 times 16 is just 16. So we're multiplying by 0, which gives us 0. So it means there's no more terms. So we now have a gradient function. And we can use that gradient function to work out what, where our maximum and minimum points are. Because we've just said the maximum and minimum points, the gradient is 0. So we can say that at the maximum or the minimum point, then dy by dx equals 0. So we're stating why we're now making this equation equal to 0, because communication at A-level maths is really important. We have to explain why we've made this equation 0. Okay, now at GCSE, to solve this equation, you would either factorise or you'd use the quadratic equation. So at A-level, you're expected to know everything that's on the GCSE syllabus. So you don't have to be tested on how to solve an equation like this, because what you do have to do is you need an A-level calculator, and the A-level calculator will solve it for you. So you see over here on the board, I've got an example of the A-level calculator. They are about £25, so I'll just warn you on that we do need to have a new calculator if you're going to do A-level maths. You can have a graphical calculator, but this is a minimum that you need. Okay, so I'm just going to show you on this calculator how we would solve this equation. We're going to go on to menu. There's lots of different menus on this calculator, and lots of different functions that you will need to use A-level maths. Statistics is one of them. So we're going to go on to the equation of function. We're going to do a polynomial. Polynomial just means it's an equation with powers of x that are whole numbers. So the degree is 2, because that's just the highest power. So degree of 2, and now we can type in our equation. So there's a 3 in front of the x squared, so I'm typing in 3. There's a minus 8 in front of the x, typing minus 8, and we've got a negative 4 at the end. And I press equals, and that's our first value. Press your SD just like your GCSE calculator, and we've got it as a decimal. So one of our solutions then is x equals 3.097. Is that right? I can't see it with a reflection. And then the second equation, we can go our arrow button down, again at SD, and we've got our second value. So we've also got x is minus 0.431. Okay, what's that telling us? It's telling us that the x values of the maximum point and the minimum point. So to find the actual coordinate, all we're doing now is substituting these values back into our original equation, and we've got our y value. So I'm sure you can just type that in your calculator. So I'm going to let you know what those y values are, because I did it earlier. This is the one I did earlier. So y at this point is minus 5.05, and y at this one is 16.90. Okay, so what we've done now is we've found where we cross the y-axis, we've found where we cross the x-axis, and we've found our maximum and minimum points. So what I'm going to do now is show you what that graph looks like, and we can check all our calculations. So this is a website that you can use. It's a free website called Desmos. So if you want to just Google Desmos, it's like a graphical calculator where you can type in the equation and then it draws a graph for you. So I'm just going to type that equation in now. So it's y equals x cubed minus 4x squared minus 4x and plus 16. And there we have our graph. And if you can see, we've got our maximum point, which we did calculate. We're crossing the y-axis at 16. We're crossing our roots are at -2, 2 and 4. And our minimum point is as we calculated it. And that's how you would sketch a cubic graph. So thank you for listening and best of luck with your GCSEs.